Okay, number 2. We're given the graph y equals f of x below, and based on that graph we have to make a judgment call about the definite integral from -2 to 3 f of x dx. So if you remember back to Friday, if the function dips below the x-axis like this one does, then the definite integral doesn't give you an area, it gives you a net area. It's the area above minus the area below. Now based on this picture, there seems to be a lot more area below the x-axis than there is above. And so the answer here would be negative, because there's more area below the x-axis than above the x-axis. And so that's number 2, just a quick concept question. And now on to number 3. We actually do some computation. Part A, find the net area between the curve y equal 2 minus square root x and the x-axis over the interval 1 to 5. So if I just want net area, I can just integrate from 0 to 5, 2 minus square root x dx. That's the integral from 0 to 5. 2 minus, rewrite that as a power. Antiderivative of 2, 2x. Antiderivative of x to the 1/2, 2/3 x to the 3/2. Evaluating from x equals 0 to x equals 5. I toss in x equals 5. 2 times 2 times 5 minus 2/3 times 5 to the 3/2 minus, toss in the 0, 2 times 0 minus 2/3, 0 to the 3/2 power. This adds up to a whole bunch of nothing. Final answer, 10 minus 2/3, 5 radical 5. So it's 10 minus 10 radical 5 over 3. This represents the net area. Part B, find the gross area between the curve and the x-axis. So this is the area above plus the area below. So I can't just blindly integrate anymore. I need to actually sketch the graph of this thing. Let's see. When x equals 0, the square root of 0 is 0. 2 minus 0 is 2. When x equals 5, I get 2 minus the square root of 5. And what's 2 minus the square root of 5? Well, the square root of 5 is bigger than the square root of 4, which means by the time I get here to 5, I've got a negative number down here. So somewhere it's got to cross the x-axis. And that's the big question. Where does it cross the x-axis? So I need to find the x-intercept. To find the x-intercept, I set my y equal to 0. 0 is 2 minus radical x. You go through the algebra, you get x is equal to 4. So what I need to do is break up the integral. I can go from 0 to 4, find that answer, go from 4 to 5, take the opposite of that answer, and then add them up. So the integral from 0 to 4, 2 minus square root x dx. From before, we already know the antiderivative. It's 2x minus 2/3 x to the 3/2. Evaluating this from 0 to 4. Well, when we plug 0 in, we already know everything zeroes out. So it's just a matter of plugging in the 4. 2 times 4 gives you 8 minus 4 to the 3/2 is 4 square root of 4. 4 times 2 is 8. Times 2 is 16. 16/3. So I combine this 24 thirds minus 16 thirds is 8 thirds. Now we integrate from 4 to 5. 2 minus square root x dx. Same antiderivative as before. From 0 to 4. Excuse me, not from 0 to 4. From 4 to 5. And we actually already know all these values. When I plug in 5, I get 10 minus 10 radical 5 over 3. When I plug in the 4, I get 8 thirds. So if I get a common denominator of 3 here, what do I get? 30 thirds minus 8 thirds is 22 thirds minus 10 radical 5. And this is where we have to think a little bit, folks. Between 4 and 5, this thing is below the axis, which means this number, even though it doesn't look like it, is actually negative. So if I want the gross area, what do I need to do? I have to take this number, 8 thirds, which is the area, which is positive because that's where it's above the axis, and then I have to add the absolute value of this number. I have to add the opposite of this number. So whatever this number works out to be, it's negative something. Alright, so the way we take the absolute value, that is, we multiply it by negative 1. If this answer were negative 3, we would drop the negative. That's the same as multiplying it by a negative 1. So we're going to take 10 radical 5 minus 22 over 3. These have the same denominator. And so my final answer is 10 radical 5 minus 14. And that's the actual retail value of the gross area. The area above plus the area below. And that'll do it for checkpoint 2.